Hi guys, welcome to another episode of Learn with Sir Glenn, and for this video, we're going to discuss distinguishable permutations. So, let's go! So before proceed with distinguishable permutation, let's review first your permutation. So according to the permutation, it is arrangement of objects with no repetition where order is important. So let's say we want to list all the arrangement that can be done using the letters A, B, and C. So if we're going to list down all the arrangement that can be done using the letters A, B, and C, we will have ABC, ACB, BAC, BCA, CAB, and CBA. So since we have here 6 different arrangements of the letters A, B, and C, therefore we will have 6 permutations for the letters A, B, and C. So now let's try this one. So list all the arrangements that can be done using the letters A, D, and D. Notice that this example is different from the previous one since the given letters here have identical letters. But if we're going to list all the arrangements that can be done using these letters, we're going to list down the arrangement the same manner that what we did on the previous example. So therefore, the first arrangement will be ADD. Then we're just going to interchange the second and the third letter, and that will give us ADD. Then after this, we will have DAD. Interchanging the second and the third letter will give you DDA. Then we will have another DAD. Then interchanging the second letter and the third letter, we will have DDA. So notice that on our list of arrangements, there are identical arrangements such as ADD, DAD, and DDA. So since these are identical arrangements, we cannot distinguish the arrangements. If we want to count the number of arrangements that can be done using the letters ADD, we're just going to count the distinguishable arrangements. So therefore, this set of letters here, the ADD and the other ADD will be considered as 1. The DAD and the other DAD is also 1. And DDA and the other DDA is also 1. So counting the number of distinguishable arrangements, we will only have 3 distinguishable arrangements. Those are ADD, DAD, DDA. So what we did here is an example as distinguishable permutation. But what is distinguishable permutation? So distinguishable permutation, from the name itself, are permutations that can be distinguished from one another. The distinguishable permutation happens if you're arranging identical objects. So since you're arranging identical objects, interchanging the position of those identical objects will give you the same arrangements. So thus, we're going to count only the distinguishable permutation or the distinguishable arrangement of objects. How do we solve for the distinguishable permutation? To solve for distinguishable permutation, we can use up this definition. For a set of n objects of which n sub 1 are alike and one of the kind, and n sub 2 are alike and one of the kind, and so on up to n sub k, the k type, the number of distinguishable permutation of these n objects is n factorial over n sub 1 factorial, n sub 2 factorial, up to n sub k factorial, where n is your number of objects that you're going to arrange, and n sub 1, n sub 2, n sub 3, n sub k, and so on are the number of objects of the same kind. So how to use the formula? So let's have this example. How many ways can the letters of the word teen be arranged? So since we're going to arrange the letters of the word teen, T-E-E-N, and there are identical letters, identical objects, which is letter E, we're going to use the distinguishable permutation formula to find the number of arrangements that can be done with these letters. So the formula is n factorial over n sub 1 factorial, n sub 2 factorial, and so on up to n sub k factorial. So to use the formula, we have to identify our n, which is the number of objects that we're going to arrange. And for this one, we're going to arrange 4 letters, which are the letters of the word teen. So therefore, n is equal to 4. Then after this, we're going to identify the n sub 1, n sub 2, and so on. And these are the objects of the same kind. So in our set of letters, we have letter T, and there is 1 letter T. Then we have 2 letter E. Then we have 1 letter N. So the n sub 1 will become 1, the n sub 2 will become 2, and n sub 3 will become 1. So therefore, if you use the formula, we will have 4 factorial replacing n with 4 over n sub 1 is the number of t, so 1 factorial, n sub 2 is the number of e, so there will be 2 factorial, then n sub 3 will be the number of n, so there will be 1 factorial. And notice that since we only have one letter t and one letter n, and that will give us 1 factorial and another 1 factorial in our formula, we can now remove those 1 factorial. So therefore, we're going to have only 4 factorial over 2 factorial. So to make it easier to solve for the distinguishable permutation, instead of listing all the kinds of objects on your denominator, we're just going to get the repeated objects on our denominator. Solving for this by reconciliation, we're going to expand 4 factorial up to 2 factorial so that we can cancel the 2 factorial on the numerator and 2 factorial on the denominator. Then leaving us with 4 times 3, which will give us 12. So if we're going to arrange the letters of the word teen, we will have 12 distinguishable arrangements. Okay, so let's have another example. So how many ways can the letters of the word kababayan be arranged? So since in the word kababayan, there are repeated objects, or in the word kababayan, there are identical letters, namely letter A and letter B, we're going to use the distinguishable permutation formula. N factorial over n sub 1 factorial, n sub 2 factorial, and so on up to n sub k factorial. So to use the formula, we identify the n first, the number of objects we're going to arrange. So in this example, we're going to arrange the letters of the word kababayan, which compose of 9 letters. So therefore, our n is equal to 9. So after this, we list down the repeated objects. So instead of listing down all the kinds of objects that we're going to arrange, we're just going to list down the repeated objects, so to make our solving easier. So first we have 4 letter A, and then we have 2 letter B. So our n sub 1 will become 4, and n sub 2 will become 2. So in our equation, we will have 9 factorial replacing n with 9 over 4 factorial, that will be our n sub 1 times 2 factorial, which is our n sub 2. Then solving for this, we're going to expand 9 factorial up to 4 factorial. Then we expand 2 factorial. So that will give us 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial times 2 times 1. So notice that we did not expand the 4 factorial on the denominator because we can cancel it right away with the 4 factorial on the numerator. Then since we still have numbers on our denominator, we can still cancel this one with the numbers on our numerator. So for this one, we can cancel it with 8 or 6 since 8 and 6 are both divisible by 2. So for this, we can cancel 6 and 2, and that will leave us with 3. So all we have to do is to list down the remaining numbers, which are 9 times 8 times 7 times 3 times 5. And solving for this, we will have 7,560 distinguishable arrangement. Okay, so let's try this example. So how many ways can the letters of the word kababayan be arranged if the word should start with N? So this is almost the same with the previous one, except that this time we are given the condition that the word should start with letter N. The same with the previous lessons that we already discussed on our videos, told you that if you're solving for a problem with a given condition, you have to satisfy that condition first before solving your problem. So therefore, if we're going to arrange this set of letters, we will have 9 places. Since according to the condition, it should start with letter N, we're going to put letter N on the first letter. So after doing this, we already satisfied the condition. So since we already have here letter N on our first position, we're going to arrange only for the remaining 8 letters. And those are the letters of kababaya on our given set of letters. So removing letter N from our choices because we already placed the letter N on our first letter position. So using the formula, we will have n factorial over n sub 1 factorial, n sub 2 factorial up to n sub k factorial. We have to identify our n. So since we're going to arrange only the remaining letters of the kababaya, the 8 remaining letters, our n is equal to 8. After this, we're going to list down the identical objects or identical letters on our set of letters. So we have 4 letter A and 2 letter B. So solving for this, we're going to replace n with 8. So we will have 8 factorial over n sub 1 will become 4. So 4 factorial, n sub 2 will become 2. The identical objects on our set of letters. Then solving for this, we're going to expand 8 factorial up to 4 factorial, and that will give us 8 times 7 times 6 times 5 times 4 factorial over 4 factorial. Then we're going to expand the 2 factorial 2 times 1. Then we're going to cancel everything that we can cancel, just like 4 factorial over 4 factorial. Then 2 can be cancelled with 6, leaving us with 3. Then the remaining numbers will be 8 times 7 times 3 times 5, that when you multiply, you will have 840 distinguishable arrangements. Okay, so let's have another example. So how many ways can 4 identical math books and 3 identical English books be arranged on a shelf? So the distinguishable permutation is not applicable only on letters. It is also applicable when you arrange identical objects. For example, you're going to arrange these 4 identical math books and 3 identical English books on a shelf. So since we have here identical objects, we're going to use distinguishable permutation, and the formula is n factorial over n sub 1 factorial, n sub 2 factorial up to n sub k factorial. Then after this, we're going to identify the n, which is the number of objects that we're going to arrange. So since we have 4 identical math books and 3 identical English books, we're going to arrange 7 books. So our n is equal to 7. Then after that, we're going to list down the identical objects. So we have 4 identical math books and 3 identical English books. And replacing the variables in our formula, we will have 7 factorial over 4 factorial, 3 factorial. Replacing n with 7, n sub 1 with 4, and n sub 2 with 3. Then to solve this, we're going to expand 7 factorial up to 4 factorial and expand 3 factorial up to 1. So cancel 4 factorial and 4 factorial. And notice that we can still cancel some of the remaining numbers, just like 2 and 3 will give you 6, so we can cancel it with 6. So therefore, we will only have here 1, and the remaining numbers will be 7 times 5. So notice that we're not putting the 1 because that is identity for multiplication. So meaning, whatever you multiply with 1 will have the same answer. So we're just going to have 7 and 5. So 7 times 5 will give you 35 distinguishable arrangement. Okay, so let's have the last one. So in how many ways can you arrange 4 red marbles, 6 blue marbles, and 2 green marbles in a row? Since you're arranging red marbles and the red marbles are identical, same with the blue marbles and green marbles, then we will have distinguishable permutation. So formula n factorial over n sub 1 factorial, n sub 2 factorial up to n sub k factorial. Then we will have our n, which is the total number of objects that we're going to arrange. And for this one, we're going to arrange 12 objects because we have 12 marbles. Then we're going to list down the identical objects. We have 4 red marbles, 6 blue marbles, and 2 green marbles. Then using our formula, we will have 12 factorial over 4 factorial, 6 factorial, 2 factorial, replacing n with 12, n sub 1 with 4, n sub 2 with 6, and n sub 3 with 2. Solving for this, we're going to expand 12 up to 6 factorial because that is the biggest factorial in our denominator. So therefore, we will have 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial. Then we're going to expand 4 factorial as 4 times 3 times 2 times 1. Then we have the 6 factorial. Then 2 factorial will become 2 times 1. Although you can cancel any of those factorials on your denominators, but normally, we pick the biggest factorial to make our numbers smaller. So therefore, we're going to cancel 6 factorial on the numerator and the 6 factorial on the denominator. And looking at the remaining numbers, you can still cancel some of your numbers, just like 4 times 3 is 12. So therefore, we can cancel it with 12. So the 4 times 3 on the denominator, you can cancel it with 12 on the numerator. Then we still have 2 on our denominator, which can be cancelled with 10. So 10 divided by 2 is 5. Then we still have another 2 on the denominator, and we can cancel it with 8. So 8 divided by 2 will leave you 4. So after this, listing down the remaining numbers, we will have 11 times 5 times 9 times 4 times 7, and multiplying this will give you 13,860 distinguishable arrangements. So okay, that's it. Thank you for watching and hope you have learned something from this video.